In this video, we're going to make use of Excel's min function to ensure we don't depreciate our asset below its estimated salvage value. This can be a problem using the units of production or when using the double declining or other declining balance methods. Under our units of production method, we calculate our depreciation expense by taking our cost minus our estimated salvage, and then of course spreading that cost over the useful life, which in this case is, instead of years, it's number of units. So we're going to take equals our $100,000 cost minus our $10,000 estimated salvage value and divide that by the useful life. So every time we produce 1 unit using our equipment, we're going to take $1 worth of depreciation expense. And that rate is going to remain constant over our asset's life unless we were to have a change for some reason. All right, so our annual depreciation expense that first year then will be the number of units we've produced. And notice our usage after the fact exceeds our 90,000 estimated useful life. So we are going to run into a problem, we'll see. But we're going to take that 20,000 units, multiply it by our rate per unit, and in that first year we would take $20,000 in depreciation expense. Our accumulated depreciation at that time would be the prior year's accumulated, which right now is 0, plus 20,000 for 20,000 in accumulated depreciation. Our net book value is the prior year's carrying value minus the current year's expense of 80,000, or we can take the carrying value, and I'm going to anchor that, minus accumulated depreciation. So 80,000. Second year, we again have 20,000 units times, second year we've got 20,000 units times $1 per unit. Our accumulated depreciation now is the 20 from the prior year plus the current year's 20,000 expense. And our carrying value will be the prior year's carrying value, which is what, 80,000, minus the current year's expense of 20. And using this row, I can copy that down. Now, you can see we've run into some problems here. In that 5th year, when we've taken more than 90,000 or produced more than 90,000 units, we've suddenly depreciated below the estimated salvage value. In fact, we've depreciated to a $5,000 negative asset value, which makes no sense whatsoever. What can we do about that? Well, again, we said we never want to depreciate below our remaining salvage value. So we can always calculate how much can we still depreciate our asset. And in that first year, we can depreciate up to $90,000. The 100 from the current carrying value minus 10, we could take up to 90,000 expense. The second year, we started the year with 80,000. We don't want to depreciate below 10, so we could take up to 70,000 in expense. In the third year, we've got 60,000 left over from year 2, minus our estimated salvage value. We could take up to 50,000 in depreciation expense. And then in the 4th year, we've got 35,000 minus the estimated salvage of 10. We could take up to $25,000 in depreciation expense. In the 3rd year, though, look what happens. We've got a carrying, or 5th year rather, we've got a carrying value of 15. We don't want to depreciate below 10. So the most we would want to take in depreciation expense is $5,000. So we can make use then of Excel's min function. We're going to take the minimum of 2 things, equals the min of the depreciation like we would normally calculate it, or that remaining depreciable cost. Now I can copy that formula down, and I don't go below my $10,000 estimated salvage value. Even if I produce 50,000 units in the second year, notice I quit taking depreciation once I've taken the full $90,000 in depreciation expense that I'm entitled to take because my machine cost 10 and I think the estimated salvage is cost 100, and I've got an estimated salvage of 10. Now, instead of the J13, what was it that we did right here? We simply took the prior year's cost minus the estimated salvage. You can anchor numbers by putting dollar signs in front of both the row and column. So this will always go to cell E6. Now I have a formula that I can copy down, and this will work for any levels of output.